What I love about mathematics is that it can answer questions once and for all. Of course, research continues, and at some point we'll be able to deal with much more complicated problems. But what you've proved once is proven forever. My name is Gustav Holzegel. I work in the field of partial differential equations and on the analysis of the Einstein equations.
Gustav Holzegel is a specialist in the area of Einstein's field equations. These also describe the existence of black holes, which is one of the greatest mysteries of the universe.
I've always been drawn to this transition between mathematics and physics and the relationship between mathematics and physics. That's exactly what fascinates me about the Einstein equations. They're formulated in the language of differential geometry, which is the language of pure mathematics. And they'd make just as much sense if bending of light or black holes didn't exist. The fascinating part is that this language is suitable, in fact, for describing our universe, black holes, or bending of light.
Gustav Holzegel made a profound breakthrough at the Imperial College London. He was able to find a mathematical proof for the stability of black holes. In other words, he was able to control the dynamics of the nonlinear Einstein equations near a black hole.
As soon as you talk about natural laws or try to describe reality in any way, you have to do it in the language of mathematics. Language, as we have it, with all its ambiguities, is the wrong medium and not appropriate to describe scientific phenomena.
More than 100 years ago, Albert Einstein already described what would revolutionize our understanding of the cosmos. He connected the three dimensions of space, height, width, and depth, with a fourth dimension, time. We can imagine this space-time like an elastic trampoline. Large masses, like the mass of a planet, cause a dent. Einstein thus describes gravity as a curvature of space-time. Space-time is bent the most by black holes. Their gravity is so strong that not even light can escape it.
What's ingenious about Einstein is you can write down the equations without understanding them completely. I think what he's given us will keep us occupied for the next 100 years. That's what makes it so appealing. One of the challenges with Einstein's equations is that they're very elegantly formulated. Mathematicians would say they're coordinate invariant. However, in order to do the analysis, you have to write down the equations in certain coordinates, and then they become very complicated.
After studying physics, Holzegel turned his attention to pure mathematics. He sees himself as part of a strong network that addresses the most exciting questions of our time.
Collaboration with Gustav has been an excellent experience. It's very helpful to work with people who think about problems differently from yourself, and hence make you think about them differently yourself as well. And in that respect, I've learned a lot from Gustav.
After working in Cambridge and Princeton, Gustav Holzegel's path led him to London in 2012. He was motivated by the international research environment of the metropolis. The idea of networking is something that he would like to take with him.
I've always been eager to take some of the broadness and the traditionally close relationship to physics from the UK to Germany, and then to build on that here.
Gustav Holzegel will now continue the mathematical research on black holes at the University of Münster. In particular, he wants to further develop the methodological competence of geometric analysis and partial differential equations.
The Humboldt Professorship offers completely different opportunities than I would have dreamed of for the move here to Münster. It enables me to build up a large group and also to invest in new research fields. I can invite guest researchers, people from areas that I would like to perhaps work in the future, to learn something. And yes, that really creates opportunities that I couldn't have imagined before.
Alexander von Humboldt Professor Gustav Holzegel helps us to understand the world a little bit better through mathematics.